Yes, because the other class is exactly the same, and then I hope that I do better in this class, or I fix my timing. Sometimes I run out of time in the other class. All right, so number 13. That was the one that you guys have seen now twice. How many actually got an answer? Okay, let's see. All right, so I'm going to do exactly the same thing. I'm going to work through the question. I'm going to show you my thought process. Acceleration is given. It tells me that the velocity of a body is... All right, so things that I do. I always write down functions if they give them to me. Do you see this information right here? That to me is something I call an initial point. The velocity of 1 is 25. Anytime I see a point, I just call it an initial point and I write it down. Or I circle it, I highlight it. All right, so S sub t is the distance of the body from the origin. So let's start with the question. The question is S sub 4 minus S sub 2. There's a few ways to think of that. That is the exact definition of displacement. Okay? Exact definition of displacement. So, other way to think of it would be, side note, I know that if I take the integral from a to b of f of x dx, that gives me the antiderivative of b minus the antiderivative of a. So someone's antiderivative is here, b minus a. Does that look similar to what's here? Okay. So this is supposed to be big F. So then what's little f? Velocity. Okay. So do we agree that that is actually the same as the integral from 2 to 4 of the velocity? Does that make sense? Okay. With that said, could you have done that with definitions? Yes, because I gave you the definition of displacement before, right? So I gave you that definition. It's the same thing. So there's two different ways to see that. Now, with that, if I know velocity, then I would take its antiderivative and go 2 to 4. So I just got to find velocity's function because I don't have it, but I have acceleration. So velocity would be the antiderivative, which gives me 8t minus 3t squared. Antiderivative, what do I have to have in the end? Plus c. They didn't give me the exact... They gave me 1 point. That's all you need is 1 point. So how does that 1 point help you? Substitute it in. Math is a lot of substitutions. That's pretty much all it is. And v of 1 is the same as how much? 25. You see how I write my initial point? I write it in notation so that I can use it in notation. So I get that c is 20. So now that I know c, how is that helpful? Because now I have the actual function exactly. So now, 20. Just kidding. That is 20. All right. Do I have enough to do the problem now? Yeah, now I would do the antiderivative. F of 4, f of 2, and subtract them. So that's actually one way. There is one other way to do the same exact problem. You could forget about doing integrals. You could find the actual function for velocity, and then you can do the antiderivative to find the function for position. When you do that, so this is method 2. Method 2 says 4t squared minus t cubed plus 20t. You need another constant. Please don't use the same constant. Now I have a d, because it's a new function with a new constant, so I use a new constant term. You won't be able to find the d, but you don't need it. Because you're going to find s sub 4, and it'll have a plus d in it. Then you're going to find s sub 2, and it's going to have a plus d in it. But what are you going to do between them? Subtract. So what happens to the d and then the other d? They cancel anyway. So that's method 2. Some people like that method way better. I don't care. I like both. So you have an option. But this is another problem where you really have to think. Integrals are tricky. Every time you take an integral, there is an unknown piece. It's either a plus c or you need the initial point. So you always want to think about an antiderivative, an integral. You always need extra information. It sucks. It's different from a derivative. You need more than just finding the function. You need an extra initial point to find the exact functions. All right, we good? All right, heads up please, all the way. Thank you. So I think those were the two that I wanted to go over. Were there any others that were really tricky that you wanted to discuss? 38, you're going to have to help me and give me a second while I go find 38. Oh. What was 38? Can you just read it to me? Was there more than one? Because there might be. All right. Laura, what? You have the problem? Because I'm going to bring it up right now, I think. Danny doesn't know. He was busy sniffing oranges. He don't know. Where is this? Is it not showing up? Okay. Okay. It's a transformation. So it's actually a really, really easy problem, but it can get confusing. You want to think of it as a transformation of what happened. Given this function, they're actually transforming it back to original f of x. So what I would do is draw a function, doesn't matter what it looks like, from 1 to 2, and that would be this. Then you have to think about, there was a minus c and now it's gone. So how do you get for the minus c to go away? What transformation did you have to do to it to make it go away? Because that transformation also transforms these. So the value you get is actually very basic. So I'm not going to do it because once you see it done, you kind of just think all of them work that way. So draw a function, doesn't just squiggle line from 1 to 2, and think of it as f of x minus c. Think about, how do I transform the function x minus c to only have an x? Think of it as transformations, and that should really help you get the answer pretty quickly. All right, so just try it. If you have the question again on Monday, I will answer it then, Laura, okay? All right. Yeah, it's actually really basic, I know. All right, anything else from there? 30. Third page. This one? Oh, that was a tricky one. That's not supposed to be there. It's not supposed to be there, but I always tell people, okay, so it's not supposed to be here, but what could you have done instead? You could actually take the derivative of each of them to go back. You haven't learned that one yet. That's why. It's snuck in there. I can't remember. Yeah, you take the derivative of each of them and one of them will work. And I'll be very honest, I can't remember, but I do think the answer has an ln in it. Yeah. All right. Any others? That is on the key. Or maybe not. I might not have actually put it on the key because I knew it was one that wasn't taught yet. You learned that in section 6.4. No, 6.2. I'm lying. 6.2. Sorry. All right. Any others that you did learn how to do that you have a question on? Because if not, what was that? Do I go down from here or up from here? Oh, you guys keep getting tricked by these. So I'm going to cover this up. So I'm going to cover up the 18. All right. So you're looking at that function. Okay. So if you only had a definite integral, what's the first step to do the definite integral? Antiderivative. So the tricky part is understanding that the variable here is just x. So I forget who asked me the question, but you do the antiderivative. Is everyone good on doing the antiderivative? Okay. And then you're going to substitute in k, and then you're going to substitute in 0, and then you're going to subtract them and set it equal to 18. Because the antiderivative f of b minus f of a is equal to the same thing as the right side, which is 18. So try that and see if the answer comes out, okay? It should. I would say you might have made like a little arithmetic error. Anything else, real quickly? If not, I'm moving on. Not by much. I'll tell you what the last few minutes of class were supposed to be. Inside of your packets, that's not the right one. The notes packet. Day 6, you'll notice it's the same thing. It was just you guys working. So what I'd like for you to do, there's only 4 more minutes left of class. I'd like for you and a partner to work on this set right here. It kind of deals with fundamental theorem of calculus and some rules. I would like you to work on that. It is not for homework, though. If you don't finish it today with your partner, on Monday, that's what we're going to start with. Because you actually have enough homework, I think, tonight, because there's free response questions that I don't want to add anything more. But I would like for you to get started. Okay?